Hello everyone. In this video, I'm explaining what are random variables and types of random variables. See, now all our previous concepts, we were interested in knowing the occurrence of outcomes. In many experiments, we may be interested in the numerical characteristic associated with outcome of a random experiment. So let me elaborate this. Consider an example of tossing a coin twice and the event is getting exactly one head. How you find the probability of this event? We have done in all our previous videos. First, you have to write the sample space associated with this random experiment, that is, tossing a coin twice, HH, then HT, TH, and TT. And event is getting exactly one head. So P of E, we want to find out probability of E. First, we have to look at the outcomes which are favorable to this event. So, getting exactly one head means here there are two heads in this outcome. There is one head in this outcome. Therefore, this is favorable. This is also favorable. One head. Here there are no heads in the outcome. So, only two outcomes are favorable. That means here we are interested in knowing the occurrence of outcomes. Which outcome will occur to say that this event has occurred. So, E equal to HT probability of E is two outcomes are favorable divided by 4, which is nothing but 1 by 2. There is 50% chance of occurrence of this event E. This we did in the previous concepts, but now here we have to associate a numerical characteristic to each outcome of a random experiment. See, for example, I will define a function or the variable x as a heads number of heads when you toss a coin twice. So, how many values x can take? Number of heads means you have to count how many possible heads you will get when you toss a coin twice. So, x equal to how many values this variable can take? No head. When you toss a coin, you may not get even a single head when you toss it twice. See, this is the outcome. So, that is 0. Then you may get one head. Maximum you will get two heads, not more than two. Because when you toss a coin, it is tossing a coin twice. So maximum two heads and minimum no heads, that is 0. So these are the possible values we can assign for the variable. This variable is called as a random variable. Variable because its value keeps changing and it takes random values. That's why the name random variable. So that every outcome of this random experiment is associated with the value. See, x of hh, how many heads here? Two heads. X of ht, here there is one head. X of th, again there is one head. X of tt, there is no head, so 0. So instead of referring to the outcomes, now we can refer to these numbers. So if you want to find out probability of getting no head is nothing but probability of getting no head means it is a tail, so 1 by 4. Probability of getting one head means HTTH, two outcomes, so 2 by 4. Probability of getting here both two heads equal to 2 is satisfied for one outcome, so 1 by 4. So you can find the probability in this way also. So when we have this concept, the formula of number of outcomes favorable by total number of outcomes, why we need to introduce the random variable then? Because when you have more number of trials, here it is tossing a coin twice. If you toss a coin 50 times, then in that case, can you sit and write the entire sample space? It is quite inconvenient. So in that case, if you introduce a random variable like this, you define the variable as number of heads, then x can take how many values? 0 to 50. zero heads, no one head, two head, so on up to all 50 tosses you will get head. So that are the random values of the random variable. Then you can find out probability. So, and there are different distributions which you will study in future, different distributions which will help you to find out the probability distribution of random variable. So I hope you understood what a random variable is. So, mathematical definition of random variable is: a random variable is a real valued function whose domain is set of possible outcomes of a random experiment, that is sample space, and range is a subset of the set of real numbers and has the following properties. Means your random variable, usually they are denoted by capital letters X, Y, Z, etc. So X is a function from S, means sample space of a random experiment, to any subset of R. So it is real set. So and has the following properties. Each particular value of the random variable can be assigned some probability. So X is the random variable and it takes values x1, x2, so on up to xn and so on. So each particular value of the random variable can be assigned with some probability. Combining all the probabilities associated with all different values of the random variable gives the value 1. So this is the formal definition of a random variable, mathematical definition. Let me explain this definition with the examples. See the first example: the random variable is number of heads minus number of tails when a coin is tossed twice. So I told you random variable is a function from the sample space to the real set, real number set. Means every random variable takes each outcome as input and it produces an output that is based on how it is defined. There is no unique random variable for a given random experiment. There are different random variables for the same experiment, that depends on how you define the random variable. See now x is defined as number of heads minus number of tails. So x, I have to find out the number associated with each outcome rather than referring to the outcome. So x of h is equal to number of heads. How many heads here? 2, minus number of tails. There are no tails, 0. So 2. The number associated with this outcome is 2. Then similarly x of ht, number of heads 1, number of tails also 1. So 1 minus 1, 0. X of th is equal number of heads 1 minus number of tails here 1, which is equal to 0. X of tt, number of heads 0 minus number of tails 2, that is equal to minus 2. Therefore finally what are the values this random variable takes? 0, 2, minus 2. It need not take always positive values. It's a real number, so it takes negative values as well as positive values. So this is how we get the values of this random variable. Name of the random variable x and its values are 0, 2, minus 2. Similarly, one more example. Number of times odd number appears when a die is rolled twice. So when a die is rolled twice, so this is the sample space you will get. Now I have to assign a number to each and every outcome. The method, the definition of assigning number is number of times odd number appears when a die is rolled. See, you should not get confused here. I am not asking you to list the odd numbers appear when you uh, roll a die twice. Odd numbers means 1, 3, 5. You should not list them. It is number of times odd number appears. So x equal to, when you roll a die twice, there may be odd number in both dice. There may be one odd number in both dice. There may be no odd number. Both may be even numbers on both dice. So therefore, x equal to 0 means number of times odd number appears. How many times odd number appears? Sometimes there is no odd number, means x takes 0. Sometimes you will get one odd number. On the other die, it may be even. Then you may get both odd numbers. That means odd numbers on both dice. Then in that case, x equal to 2. X equal to 3 not possible because you are throwing a die only 2 times. So these are the possible values of this random variable. Number of times odd number appears. It is not odd number appears. If it is just odd number appears, then 135. But it is number of how many times odd number appears when you roll a die twice. There is no odd number. There may be one odd number. There may be two odd numbers. Now, similarly, define this y as number of times odd number appears when a die is rolled once. This is the same type of random variable, but here die is rolling only once. S is equal to 1, 2, 3, 4, 5, 6. These are the outcomes of the random experiment. So, how many times odd number appears when you roll a die? Either it appears or it does not appear. If it appears, the value of the random variable is 1. If it doesn't appear, then it is 0. Means when you roll a die, you may get 2. If you get this 2 outcome, then in that case, is it an odd number? No. So, number of odd numbers is equal to 0. If you roll a die and if you get a 5, then it is an odd number. In that case, number you have to count how many odd numbers. One odd number, so it is 1. Now 2 not possible because you are rolling die only once. So this is the meaning of random variable. Now what are types of random variables? There are two types of random variables. One is discrete random variable and another is continuous random variable. What is a discrete random variable? If the random variable has finite or countable number of values, then we call that variable as discrete random variable. These values can be arranged in the form of a sequence, and these discrete random variables cannot take fractional value. See, for example, number of students present in each day in a class. Then x is equal to, in some of the days there are no students in the class. There may be one student in the class. There may be two students in the class. Then three students, and so on, like this. So here x is the random variable which takes only whole numbers. There are no 2.5 students in the class. We don't say like that. There are no 3.7 students. So fractional values cannot be given to discrete random variable, and it takes finite, either finite or countable number of. Countably infinite means you can arrange them in the form of a sequence. See, for example, 1, 2, 3, 4, and so on. Though it is infinite, it is countable because we can arrange the values in the form of a sequence, and based on first few terms of the sequence we can guess what are the next values. So those values also come under the countably infinite case. Therefore such variable is called as discrete random variable. So the thing to remember is it will never take fractional values. Number of pages in a book. So number of pages in a book, 1 page, 2 page, 3 pages, 4 pages, like that. It is not taking the value 2.5 pages, 3.5 pages. That is not possible. So that kind of variable is discrete random variable. Now, how to find the probability distribution of discrete random variable? If you have a random experiment, instead of writing the sample space and writing each outcome, we are assigning now number to each outcome. So that is random variable. Once the number is assigned, then there are certain conditions for that random variable. The conditions are like, that is called as probability distribution. How to get the probability of each random variable? So suppose if you have x as a random variable, then p of x equal to xi, which is denoted as p of xi, or pi, that is value of the probability corresponding to the random value xi. This function p of xi is defined for the values x1, x2, so on, assumed by the random variable x, is called probability mass function of x. The condition for the valid probability mass function is each value of the probability should be greater than or equal to 0, and sum of all the probabilities must be equal to 1. When you add all the values of probabilities, then you have to get the value 1. Such a function is called as probability mass function. See, p of x equal to xi means small letter p of xi means value of probability at xi is the value of the random variable, which is denoted as p of xi or pi. So probability distribution of this random variable is represented in the tabular form as x is the name of the random variable which has values x1, x2, x3, so on, and p of x is the probability of random variable which takes the values p of x1, p of x2, or p of x3, or we can write it as p1, p2, p3, and so on. The condition for probability mass function, which is also called as PMF, is that all these P1, P2, P3 should be greater than or equal to 0. And when you add all these values, you should get the value equal to 1. Sum of all these value equal to 1. See some problems. State and give reason which of the following are not probability distributions. X, this is the random variable which takes two values 0, 1, p of x 1 by 2 and 3 by 4. Look at each probability values. They are positive. First condition is satisfied. Second condition is sum of probabilities. This is equal to 5 by 4, that is greater than 1. So this is not a probability distribution. Second example, probability values here positive, this is negative minus 1 by 2 which is less than 0. So first condition is violated. This is also not a probability distribution. Third example, 0, 1, 2 values of random variable, its probability values are 1 by 4 plus 1 by 4 plus 1 by 2, all are positive and all add up to 1. Therefore, this is valid probability distribution. Here in this case, 1 by 8 all are positive here. So you will get 5 by 8 plus, this is 5 by 8 plus then 1 by 4 which is equal to 7 by 8, that is less than 1. Therefore, this is also not probability distribution. So this is how we identify valid probability distribution. So now instead of writing the outcomes of a random experiment, we are assigning the number to each outcome. They will define how x should be. Based on that, you have to get the value of random variable. Once you get the random variable and if you find the probability distribution should satisfy the condition. Each probability value should be greater than or equal to 0 and sum of all probabilities must be equal to 1. See the second question. Find the probability distribution of number of heads when three fair coins are tossed simultaneously. So sample space is HHH, three coins HHT, HTH, HTT, then TTH, THT, THH, TTT. So this is the sample space. So what is X random variable? Number of heads. Number of heads. So, how many values x can take? Some of the outcomes there is no head. In some of the outcomes there is one head. In some of the outcomes there are two heads. Then maximum three heads. Now you have to get the probability distribution. P of probability of this random variable at 0 because the first value is 0. This meaning of this is probability of the random variable at the value of random variable 0 equal to which outcomes do not have heads? 0. No head means only one outcome out of 8 outcomes. P of x equal to 1, which is equal to. Now, for the understanding purpose, we are writing the outcomes and then we are finding the probabilities. As you go on, then different types of methods to find the probability distribution. Now, P of x equal to 1, one head means this outcome, 2 then 3. 3 outcomes will satisfy. P of x equal to 2, 2 heads, 1, 2, then 3. 3 outcomes. Then P of x equal to 3, all 3 heads, only 1 outcome. Therefore, now probability distribution should be written in terms of table. Probability distribution is x random variable p of x, its probability. Random variable takes the values 0, 1, 2, 3. What are corresponding probabilities? 1 by 8, 3 by 8, 3 by 8, 1 by 8. So each probability value is positive, and sum of all probabilities 6 plus 1 7 plus 1 8, 8 by 8, that is 1. Therefore, this is the probability distribution of number of heads when 3 fair coins are tossed. Similarly, you can find probability distribution of number of tails also. You will get the same thing. See, third question. For the following probability distribution of a discrete random variable x, find constant k, then find probability x less than or equal to 3 and probability of x in between 1 and 4. So, first let us find out the value of k. This is given, it is the probability distribution. So, if it is the probability distribution of a random variable, then it satisfies those two conditions, each value positive and the sum of all probabilities is equal to 1. So add all this k plus 2k plus 3k plus k, that must be equal to 1. This is 8k equal to 1, k equal to 1 by 8. So you will get here 0, k is 1 by 8, 1 by 8, 2 by 8, 3 by 8, 1 by 8. Now you want the first question answer we got. Second question, p of x is less than or equal to 3. P of x less than or equal to 3 means x will take the values 0, 1, 2, 3 up to 3. Okay. Therefore, p of x equal to 0. You have to find out one by one. X equal to 0 plus p of then x equal to 1. Add all these values. P of x equal to 2. Then plus p of x equal to 3. What is probability at x equal to 0? 0. Plus at x equal to 1, 1 by 8. Plus at x equal to 2, 1 by 8 plus 2 by 8. Now add all these, which is equal to 4 by 8, that is 1 by 2. Now, second question done. Third one, P of x probability is in between 1 and 4. The random values are in between 1 and 4 means P of x equal to 2 comma 3. What is probability at x equal to 2? That is 1 by 8. At x equal to 3, this is 1 by 8, this is 2 by 8. So answer is 3 by 8. So this is how we find out the probabilities using the values of random variable. See here, nowhere the random experiment or its outcomes are specified. Instead of outcomes, now we are dealing with the number associated with each outcome. Now, second type is continuous random variable. See here, in this case, values of random variable cannot be arranged in a sequence form. For example, temperature of a city at various point of time during a day. It is taking the fractional value also. Say when you have real numbers, you can't write the real numbers in sequence form because if 2.1 is real number and 2.2 is real number, then in between 2.1 and 2.2, 2.11, 2.111, there are infinite real numbers. So they can't be written in sequence form. So continuous random variable means that kind of random variable where it takes any random fractional value also. Temperature of a city need not take only whole number. Temperature like 40 degrees Celsius, 40.2 degrees Celsius, 40.5 degrees. So it takes fractional values as well. Continuous random variable takes fractional values. It takes all possible real values between two certain limits. One more example is height of a person. That also takes fractional values. Here the chance of occurrence of a particular value of the variable is very small, because it can take any random value in between two values. So for example, height of a person, it can be in between. So generally in a class I'm taking, it may be in between 4 feet to 6 feet. So in between 4 feet to 6 feet means, see for example, if you want to find the probability of a person having 4.8 feet or 4.6 feet or 5.3 feet, so it will be very very small, because there are n number of values, there are infinite values in a range. So in this case we don't find the probability of a particular value. Instead of specifying the probability of taking a particular value by the variable, here we specify the probability of it's lying within an interval within 4 to 4.5. Within that range, what is the probability of having height 4 to 4.5? We find it in that way when you have a continuous variable, because if you go with each and every particular value within that interval, its probability is very very small. This continuous random variable probability distribution is represented by a new function, which is probability density function. It is not probability mass function. So we can write it as a PDF. PMF is for the discrete random variable, where we are finding the probabilities for each and every value of random variable. Here in this case, as this random variable takes fractional values also, you can't keep on finding probabilities for each and every fractional value. So instead of that, we are finding within a given range, within a given interval. So that's why here it is probability density. So probability density function is defined as limit delta x tends to 0 p of, this is the mathematical definition of probability density function. The condition for probability density function, same as the previous one, sum of all probabilities must be equal to 1. But here in this case, as it is taking fractional values also over the interval, that's why summation is replaced with the integration. Integral of f of x dx over the given interval r, which is equal to 1. Sum of all the probabilities must be equal to 1. That is integral of that PDF, probability density function, should be over the given interval should be equal to 1. And if you want to find out the probability of a random variable, continuous random variable x will be between two values a and b, which is given as integral from a to b f of x into dx. This is the definite integral, where f of x is the PDF. Using that probability density function, you can find out its probability distribution. So let us take one example. See, a continuous random variable x has this as a probability density function. So find the value of A. So as per the definition of probability density function, integral of f of x over the given interval must be equal to 1. That is the condition of probability density function for having the valid distribution. Now here the given interval is 0 to 1. So 0 to 1, and the density function is ax cube with respect to x, that must be equal to 1 to find the value of a. So now integrate this. A is a constant. Integral of x power 3 is x power 4 by 4. Limit is from 0 to 1, that is equal to 1. Now evaluate this. Limit a by 4, upper limit is 1 minus lower limit is 0, which is equal to 1. So a by 4 is 1, which implies a equal to 4. The value of constant a here, it is 4. Second question, P is in between zero point 0.2 to 0.5. Within this range, now you have to find out what is the probability. What is the probability of having any value of the random variable in between zero point 0.2 to 0.5? So 0.2 is the lower limit, 0.5 is the upper limit, and here you have to write the probability density function, which is already given. So 0.2 to 0.5. Now we know the value of A, 4. x cube into dx, which is equal to 4 is a constant. Integral of x power 3 is x power 4 by 4. You should know the concept of integration. Here onwards we'll be continuously using integration. So cancels, then 0.2 to 0.5. So upper limit is 0.5 to the power 4 minus this is 0.2 to the power 4. So the value is approximately 0.0609. Then third question, probability of x greater than 3 by 4 given x is greater than 1 by 2. Here given, so it is conditional probability. I have already explained what is conditional probability. A video is already made on that concept. So probability of, how to write this, x is greater than 3 by 4 given that x is greater than 1 by 2. So that is, using the definition of conditional probability, x is greater than 3 by 4, 3 by 4, and x is greater than 1 by 2. 1 by 2 means here zero point 0.5. 3 by 4 means it's about zero point 0.7. So this is bigger. So x is greater than 1 by 2 and x is greater than 3 by 4, which is the common region. X is greater than 3 by 4. So x is greater than 3 by 4. Because in the conditional probability, intersection we want in the numerator. X is greater than 3 by 4 intersection x is greater than 1 by 2. Intersection means common region. One is greater than zero point 0.5 and there is greater than 0.7 means all values are greater than, common is greater than 0.7. So P of x is greater than 1 by 2. This is by the formula of conditional probability. Probability of A given that B has occurred means P of A intersection B divided by probability of B. So that's why probability of x greater than 1 by 2. We have to find it one by one now. What is P of x greater than 3 by 4? Which is lower limit is 3 by 4, upper limit is maximum value is 1. So 4 into x cube into dx, which is same 4 into x power 4 by 4 from 3 by 4 to 1. So upper limit is 1 minus lower limit is 3 by 4 to the power 4. So that is how to evaluate definite integral, upper limit minus lower limit. So when you simplify this value, so the final answer is 175 divided by 256. You calculate this using the calculator. So that gives you 175 by 256. Now we need P of x greater than 1 by 2, which is equal to 1 by 2 lower limit, upper limit 1. So 4 into x cube into dx, which is equal to 4 into x to the power 4 by 4 from 1 by 2 to 1. So 4 cancels. 1 to the power 4 1 minus 1 by 2 to the power 4. This gives you 1 minus 1 by 16, which is equal to 15 by 16. So therefore, substitute in this formula P of x greater than 3 by 4 given that x is greater than 1 by 2 equal to, here this value 175 by 256 whole divided by 15 by 16. So after simplifying this, we will get 35 by 48 as the value of probability. So far we have seen what is random variable, types of random variable, and their probability distribution function. So we had two types of random variables, discrete random variable and continuous random variable. For a discrete random variable, the distribution function is called as probability mass function, and for continuous random variable it is probability density function. In both cases, the function is represented by small letter f of x. Now let us see what is distribution function. A function f, capital F, defined for all values of the random variable x by f of x equal to, here this is a small letter x, f of x equal to p of x less than or equal to x. Distribution function of a particular random value is sum of all probabilities lying below that random value. That is called as distribution function. That is also called as cumulative distribution function, CDF. Since it is the cumulative probability of x, up to and including the value of x. As you find cumulative frequency, the same here with the probabilities. So x belongs to R means random variable value. F of x belongs to 0 to 1. So distribution function is a function from set of all real numbers to this closed interval 0 to 1, because it is taking the value of the probabilities. So it is always in between 0 to 1, because sum of all probabilities maximum value is always equal to 1. So here f of x value lies within the interval 0 to 1. So distribution function is represented using capital F of x, probability mass function, density functions by small letter f of x. There are two types of distribution functions: discrete distribution function and continuous distribution function. Discrete distribution function means distribution function of that discrete random variable is called as discrete distribution function. It corresponds to discrete random variable. See, f of xi is given by capital P of x less than or equal to xi, which is sum of all probabilities up to xi, including value of the probability at x equal to xi. So distribution function of x is here given by, write the random variable values, then capital F of x is x1 is p1, then second value f of x is p1 plus p2, add the probabilities, then p1 plus p2 plus p3 up to x4 means p1 plus p2 plus p3 plus p4 and so on. That is called as distribution function. See, for example, find this distribution function for this discrete random variable. So first you write x 0, 1, 2, its probability 1 by 4, 1 by 2, 1 by 4. Now distribution function, first value 1 by 4, then add 1 by 2 this 1 by 4, then you will get 3 by 4, then add 1 by 4 to the 3 by 4, that is equal to 1. Same as the cumulative frequencies. That's why the name cumulative distribution function. So continuous distribution function. This is a distribution function of continuous random variable. Continuous distribution function. See, let x be a continuous random variable having PDF f of x. Then distribution function of f of x is given by capital F of x is equal to sum of all the probabilities which are up to x and including x. So here sum is represented using integration in the case of continuous random variable, starting from minus infinity to the value x, the given PDF into dx. So there is one remark, that is the PDF is the derivative of distribution function. F of x equal to the first derivative of the distribution function. Small letter f means it is a probability density function. Capital F means it is a distribution function. See this example problem. The diameter x of a cable is assumed to be continuous random variable with probability density function is given by this. You have to obtain the cumulative distribution function for this random variable. So f of x is a cumulative distribution function. Capital F is cumulative distribution function. This is given by probability of this random variable. So this is given by minus infinity to x f of x into dx. Now the first case is for x less than 0. So for any value x lesser than 0, then as per the definition f of x equal to minus infinity to x f of x into dx, which is equal to minus infinity to x. For x less than 0, the value of the function is 0, because only in this interval the value of the function is this, elsewhere it is 0. So 0 into dx, that gives you 0. Now for x greater than or equal to 0, less than or equal to 1, f of x equal to minus infinity to x f of x into dx. So now we have to split it as a minus infinity to 0, then 0 to x. That is because minus less than 0 there is a some other function, and in between 0 and 1 the value of the function is different. Therefore minus infinity to 0 f of x into dx plus 0 to x f of x into dx. Here 0 to x only you have to write because x is in between 0 to 1, that we have specified here. It can take any value between 0 and 1. Don't take directly 1. If you take directly 1, it is this any value in between 0 and 1. So anyway, this is 0. Now 0 to x, f of x is 6x into 1 minus x into dx, which is 0 to x, 6x minus 6x square into dx. So that gives you 6 into x square by 2 minus 6 into x cube by 3 from 0 to x. So that is equal to 3x square minus 3 1 is 3 2 is 2x cube. Now the last case, for x greater than 1, f of x is in integral from minus infinity to x f of x into dx. Now we have to split it into three integrals. One is minus infinity to 0 f of x into dx plus 0 to 1 now into f of x into dx plus 1 to x f of x into dx, where x is greater than 1. Therefore these two values of functions will be equal to 0. Therefore you are remained only with this integral. Therefore 0 to 1, in between 0 to 1, what is the function value? We know it as this 6x into 1 minus x with respect to x. So it is the integral of 6x minus 6x square into dx. Same as before, but only the difference is integral is from 0 to 1 now, which gives you 6 into x square by 2 minus 6 into x cube by 3 from 0 to 1. So when you apply the limit, this is 2 3 is a 3 into upper limit is 1 minus 3 1 is a 3 2 is a 2 into upper limit 1 lower limit 0. So 3 minus 2, that gives you 1. Therefore by combining all this, the distribution function f of x is 6, this 3x square minus 2x cube when x is in between 0 and 1, and if x is less than 0, the distribution function we got it as 0. Then if x is in between, if x is less than 0, we got the distribution function as 0. If x is in between 0 and 1, the distribution function is 3x square minus 2x cube. If x is greater than 1, in that case the distribution function is 1. This is how we calculate the distribution function for continuous random variable. Therefore the PDF is given by small letter f of x. PMF is also given by small letter f of x. Capital F of x means it is a distribution function. Small letter f of x means it is the probability density function or probability mass function. I hope you understood the concept. Thank you for watching.